Hey guys, welcome to my channel. Can you believe this? While some countries spend a decade debating a single bridge or railway, arguing over budgets that keep doubling, China has already been building world-shaking megaprojects between sheer cliffs, beneath the deep sea, and across frozen permafrost. This isn't science fiction. It's not a vision of the future. It's happening right now. Bridges soar across canyons as tall as 200-story buildings. High-speed trains race through snow-covered plateaus once considered uninhabitable, and metro systems spread through cities like arteries, connecting an entire nation at astonishing speed. That's why China has earned a global nickname, the infrastructure powerhouse. Not as sarcasm, but as a reflection of the world's genuine shock at China's engineering capabilities. As one of the world's largest developing countries, China chose a very different path to growth. Connect first, then develop. Build infrastructure first, then unlock economic takeoff. To Chinese engineers, mountains are not obstacles, oceans are not boundaries, and extreme environments are simply the next challenge to overcome. In this video, we'll take you behind the scenes of China's massive engineering projects. Projects that leave global engineers speechless and foreign audiences in awe, to see how they were built and how they're reshaping a nation's destiny step by step. If you don't want to miss these real-life engineering miracles, make sure to subscribe and turn on notifications. And let us know in the comments, which Chinese mega project do you want to explore next? As an old Chinese saying goes, if you want prosperity, build roads first. Because only when people and goods can truly move, can a nation's growth truly begin. And with a population exceeding 1.4 billion, China has no choice but to manage its resources, transportation, and energy systems in the most efficient and sustainable way possible. The infrastructure being built today is not just about expanding usable space. It is about laying the groundwork to become a global leader in technology, engineering, and energy. That includes towering bridges engineered to withstand typhoon-force winds, ultra-long tunnels driven through frozen mountain ranges, and direct sea crossings that turn vast bays into journeys of just minutes. It also includes the world's largest radio telescope, built to detect signals from deep space, and drilling projects that plunge tens of thousands of meters underground to uncover the secrets of the Earth itself. China is even transforming deserts into hubs of clean energy and new farmland, achievements once thought impossible, now becoming reality. Together, these projects show that China is not building simply to compete with other nations, but to demonstrate, on its own terms, a determined and unmistakable path toward the future. So what does that future actually look like? It looks like tunnels drilled beneath oceans, bridges hanging higher than clouds, railways carved through frozen mountains. Let's take you inside the mega projects making it real. First, let's take a look at what was once the world's highest bridge, the Beipanjiang Bridge. This dramatic canyon-spanning structure famously prompted former U.S. President Donald Trump to remark that America needs to learn from China's determination. Its construction difficulty went far beyond ordinary engineering challenges. 883-foot main towers, equivalent to stacking 2.5 Statue of Liberty monuments vertically inside the canyon. 22,000 tons of steel deck, capable of bearing 3 tons per square meter, and designed to withstand a once-in-a-century blizzard. 250 miles of steel cables, if combined into a single cable, their strength would be sufficient to lift 3 Nimitz-class aircraft carriers. U.S. civil engineering experts candidly admitted, if this bridge were built in the United States, it would take at least 12 years. China completed it in just 5. They even installed AI-based monitoring systems on both sides of the canyon to adjust cable tension in real time. As you drive across this bridge, the experience feels almost unreal. Nearly 2,000 feet below, a vast canyon opens beneath the roadway, with the Beipanjiang River surging violently at the bottom. The view is both breathtaking and unsettling. From the edge of the deck, the steep walls of the Beipanjiang Gorge drop away abruptly, and every glance downward is enough to take your breath away. Despite its enormous construction costs, the bridge shattered multiple world records through its sheer height and engineering innovation, further cementing China's position as the country with the greatest number of ultra-high bridges on Earth. But this raises an important question. Why are so many of China's bridges built so extraordinarily high? To answer that, let's step inside the remarkable story behind the construction of this bridge. The Beipanjiang Bridge is located in Guizhou Province, southwestern China. It soars above the Beipan River, with its deck standing 854 feet above the water, a height comparable to a 200-story skyscraper. The structure is a 4-lane cable-stayed bridge, Positioned along the border between Guizhou and Yunnan provinces, a region notorious for its rugged terrain and extreme transportation challenges. Spanning 4,399 feet across the canyon, the bridge provides a safe yet awe-inspiring route through a landscape that was once extremely difficult to traverse. That convenience, however, came at a steep price. The total project cost reached approximately $147 million. Completed in 2016, the bridge became the highest bridge in the world at the time, officially entering the Guinness World Records in 2018 due to the height of its deck above the valley floor. It's important to clarify that the title of highest bridge does not mean tallest bridge structure. France's Millau Viaduct, which cost around $424 million, is renowned for its towering pylons, yet its deck height above the ground is far lower than that of the Beipanjiang Bridge. The Millau Viaduct reaches a structural height of 336.4 meters, while the tallest tower of the Beipanjiang Bridge stands at 269 meters, ranking 10th globally in tower height. What the Beipanjiang Bridge truly set a record for is deck height above ground. So if anyone ever asks how much you know about bridges, here's a useful piece of trivia. Tall bridges and high bridges are not the same thing. Beyond its height, the bridge also features the second longest steel cable-stayed span in the world. But how did this structure manage to break so many records and become a global symbol of modern engineering? Construction of the Beipanjiang Bridge took 3 years, finishing in 2016, but planning and design began much earlier, in 2011. The project initially received about $1.37 million in scientific research funding from the Chinese government. Additional matching funds of roughly $937,000 were later added, bringing the total research investment to $2.3 million. Designed entirely by Chinese engineers, the bridge connects major east-west transportation corridors in Guizhou and crosses terrain that was previously nearly inaccessible to vehicles, extending directly into Yunnan province. Due to the extreme depth of the gorge, the structure had to withstand powerful wind fields generated within the valley. Engineers ultimately selected high-strength, steel cable-stayed technology, balancing flexibility with structural stability. The bridge's extraordinary height was not purely a design choice. It was dictated by geology. Early designs proposed a much lower structure, but repeated surveys uncovered fractures and karst caves within the surrounding mountains. To avoid these geological hazards, the bridge alignment was raised again and again. This iterative process of testing, adjustment, and validation ultimately produced a bridge seemingly destined to claim the world record, though it also increased the budget by an additional $20 to $40 million. In the end, it proved entirely worthwhile. Before the bridge was built, many surrounding areas were barely accessible by road. The Beipanjiang Bridge fundamentally transformed travel in southern Guizhou. The province itself is defined by mountains, plateaus, rivers, and deep canyons, and the bridge forms a critical section of the G65 Hangrui Expressway. This highway links Huajiang and Beipanjiang, stretching an astonishing 2,935 kilometers from Hangzhou near Shanghai all the way to the China-Myanmar border. After the bridge opened, what once required 3 hours of winding canyon travel was reduced to just 5 minutes. The journey between Zhenxiang in Yunnan and Jiangxi in Guizhou was cut from 5 hours to 1. As a result, the Beipanjiang Bridge is far more than a piece of infrastructure. It connects communities, enables mobility, attracts tourism, and directly stimulates economic growth in regions that were once isolated. It also represents regional integration, allowing people to move freely for the first time, no longer constrained by geography. At the same time, it stands as a symbol of China's engineering capability, financial strength, and global stature. China is famous for building extremely tall bridges, but the scale of its dominance is still startling. The country also holds the second and third highest bridges in the world, the Sidu River Bridge, standing 496 meters high, and the Puli Bridge in Yunnan at 485 meters. The Beipanjiang Bridge surpassed the Sidu River Bridge to claim the top spot, even though the Sidu Bridge itself cost nearly $100 million. Because of its dense network of deep valleys and gorges, Guizhou province alone hosts more ultra-high bridges than all other Chinese provinces combined, and more than the rest of the world combined. By 2020, Guizhou had over 250 bridges taller than 100 meters, making it the most concentrated region of high bridges on Earth. Italy, which ranks second globally, has only 40 bridges exceeding that height. Of the 20 super high bridges, worldwide with deck heights above 300 meters. All but 3 are located in China. The Beipanjiang Bridge not only shortened travel times and shattered records, it created a man-made structure that blends seamlessly into one of the most dramatic landscapes on Earth. Even today, it continues to deliver convenience and global attention, proving that its $147 million investment was well worth the cost. While the Beipanjiang Bridge seemed nearly impossible to surpass, that record eventually fell. In 2025, the Huajiang Canyon Bridge, with a deck height of 625 meters, officially overtook it, becoming the new highest bridge in the world. Now let's step inside the world's highest bridge, the Huajiang Canyon Bridge. But before a single car was allowed to cross it, the structure had already endured one of the most demanding load tests ever conducted on a bridge of its kind. 96 fully loaded trucks, a combined weight of over 3,700 tons, more than 400 sensors tracking stress, vibration, and structural behavior in real time. The purpose wasn't spectacle, it was verification, and the result wasn't just a pass. It was data that expanded the known limits of large-span bridge monitoring and safety assessment. This is not simply another record-breaking structure. It's a signal of where large-scale engineering experimentation is happening today, and how the focus of global infrastructure development is shifting in real time. So why can this bridge be seen as a true symbol of 21st century infrastructure? China is leading a once-in-a-century infrastructure transformation, building record-breaking megaprojects at a pace rarely seen in modern history. Its national high-speed rail network now extends more than 26,000 kilometers, linking cities such as Beijing, Shanghai, Shenzhen, and Chengdu. It has become a global reference point for modernization and efficiency, while laying the groundwork for long-term economic growth. In 2023, China's infrastructure investment approached $2.44 trillion, an 8% increase from the previous year. This reflects a strategic decision to position infrastructure as a central engine of economic expansion and international integration. These massive investments do more than expand global supply chains. They create opportunities for technological collaboration and innovation, strengthening China's role on the international stage. One striking example is the Huajiang Grand Canyon Bridge in China's Guizhou province, a region long divided by rugged and inaccessible terrain. Scheduled to open in September 2025, the bridge spans 9,480 feet, with a main span of 4,660 feet, reducing the crossing time over the canyon from 70 minutes to just 90 seconds. The Huajiang Canyon Bridge is not only a transportation link, it also integrates a glass skywalk, bungee jumping, paragliding platforms, and cliffside walkways, positioning it as a new landmark tourist destination, often compared to San Francisco's Golden Gate Bridge. Completed in just 3 years, the project showcases China's remarkable construction speed, its ability to overcome extreme geographic constraints, and its growing role in shaping the global infrastructure era. What makes this bridge truly astonishing is not only its scale, but its location and elevation. The Huajiang Grand Canyon Bridge spans the Huajiang Grand Canyon in Guizhou province, with a deck height reaching 625 meters above the canyon floor. To grasp this height intuitively, you would need to stand on the rooftop of Shanghai Tower, the tallest skyscraper in China, to reach a comparable elevation. Constructing a bridge at such an extreme height presented extraordinary challenges. Engineers had to contend with highly unstable mountainous terrain, as well as persistent and unpredictable high winds funneled through the canyon. Yet the objective remained singular and uncompromising: to bring the bridge into operation as early as possible, without compromising safety or structural integrity. And the height alone is not what makes this bridge remarkable. There is a saying in Guizhou: the land is never flat for 3 feet, and the sky is never clear for 3 days. This is not poetic exaggeration, but an accurate description of the region's geography and climate. More than 90% of Guizhou is covered by mountains and hills, and the Huajiang Canyon lies at the heart of this terrain. The region is celebrated for its dramatic landscapes and cultural depth, earning it the nickname China's Switzerland. Internationally, it is recognized as a major destination for natural and cultural tourism. But beauty often comes at the cost of accessibility. For decades, Guizhou functioned almost like an inland island. Reaching the province was difficult, and traveling within it was even harder. This isolation is precisely why the Chinese government has invested tens of billions of dollars in infrastructure, seeking to fully integrate the region into the national transportation network and beyond. From the opening of Guiyang Longdongbao International Airport in the late 1990s to the expansion of high-speed rail and expressways across the province today, Guizhou's transportation map has been fundamentally reshaped, yet construction is far from finished. Today, Guizhou is home to more than 32,000 bridges, one of the highest totals anywhere in the world. Built across some of the most complex terrain on Earth, these bridges provide direct, efficient routes where none previously existed. And among them, the Huajiang Canyon Bridge stands out as the most striking. Before its construction, China already held the record for the world's highest bridge with the Beipanjiang Bridge. The Huajiang Bridge has now pushed that record even further. Its deck height reaches 2,051 feet, nearly 200 feet higher than the previous record holder. This is not merely a numerical increase. It represents a qualitative leap in the design and construction of long-span suspension bridges in deep canyon environments. Before the bridge existed, crossing from one side of the canyon to the other required a 2-hour journey along narrow, winding mountain roads. Today, the same crossing takes just 2 minutes. The Huajiang Canyon Bridge is a critical component of the SA-57 Guizhou-Qian Expressway, a roughly 150-kilometer route cutting directly through the mountainous interior of the province. To build this highway, engineers went so far as to carve a V-shaped corridor through solid rock, using explosives and heavy drilling equipment, effectively splitting an entire mountain to allow traffic to pass. The expressway connects Luji Special District with Anlong County, integrating 14 interchanges and bringing once isolated areas into the modern transportation network. Within this massive system, the Huajiang Canyon Bridge is the keystone. During site selection, engineers carried out detailed studies across a corridor stretching 5 to 10 kilometers on both sides of the canyon. They evaluated soil conditions at tower foundations, rock quality, and extreme cliff heights, the required crossing width, wind behavior, seismic risk, and geological instability. After weighing all factors, one conclusion became unavoidable. Only a record-breaking suspension bridge could work. The bridge has a total length of 2,890 meters, with a main span of 1,420 meters. At this scale, the realistic options narrowed to cable-stayed or suspension designs. Engineers ultimately chose a steel truss suspension bridge, a proven and highly stable system for mountainous rock environments. The main cables are firmly anchored into solid bedrock, providing exceptional structural stability. Before construction began, engineers used virtual pre-assembly technology, digitally rehearsing the entire structure to ensure that every component could be installed accurately at extreme height. The steel truss consists of 93 segments, with a total steel weight of approximately 22,000 tons. For comparison, the Eiffel Tower contains about 7,300 tons of steel, meaning the Huajiang Bridge uses nearly 3 times as much. All of this steel was installed 625 meters above the ground. At such heights, any falling component could cause catastrophic structural and economic loss. Precision became a matter of survival. Rather than relying on the world's tallest cranes, engineers adopted a more controlled strategy. Symmetrical construction from the center outward, maintaining balance and avoiding concentrated loads. Component positioning was guided by China's Beidou satellite navigation system, achieving centimeter-level accuracy.
What we have here is using what's called a cable crane, which is an overhead system. So it's like an overhead cable runway, where the units are delivered to the ends where you've already built the abutments and concrete foundations and so on. And then you lift it up and it travels along, almost like a monorail, but it's a cable, not a rail. And then you can deliver it to where it needs to be, and then you attach it to the cable system.
Because the terrain on either side of the canyon is asymmetrical, the bridge towers are different heights. The North Tower rises 262 meters, while the South Tower stands at approximately 205 meters. The cable system uses asymmetric anchoring to maintain overall stability.
The mountainside is anything but symmetrical. And so your 2 cables at the back coming down from the tower tops, coming down to ground where the anchorages are, will very often meet the ground at completely different levels or different places. So the asymmetry will be in the anchorages. Some might be deeper than the others, depending again on the local geology, exactly where the cable meets the ground.
Although Guizhou is not located in a major seismic zone, earthquake risk still exists. As a result, engineers incorporated hydraulic damping systems, similar to large-scale shock absorbers. These systems dissipate seismic energy while allowing the bridge to expand and contract naturally with temperature changes. Wind behavior in such a deep canyon is especially unpredictable. Due to the Venturi effect, wind speeds accelerate dramatically in narrow sections of the gorge, with gusts sometimes approaching the speed of high-speed trains. Engineers relied not only on computational simulations, but also conducted extensive wind tunnel testing using scaled physical models of the bridge and canyon environment. In addition, the bridge is equipped with Doppler LiDAR systems to monitor wind speed and airflow patterns in real time. So what exactly is Doppler laser?
Doppler is a system which we know from most familiarly. When a siren goes past you, the pitch changes, and that's just the frequency shift when something's moving. LiDAR is a laser system for representing in three-dimensional space surfaces or voids, objects. And so what this is doing is using a sort of scatter of laser beams into the clouds, into the air, and measuring the frequency shift, the Doppler bit, measuring the frequency shift of the reflected signal. The signal is reflecting off moisture particles in the air. So what that's doing is building up a three-dimensional image of the moving moisture particles in the sky. And that gives you a picture of what the wind is doing.
Monitoring will continue long after construction is complete. Fiber optic sensors embedded within the main cables continuously track tension, strain, and vibration. Changes in light signals allow engineers to determine structural health with extreme precision. For a suspension bridge, the cables are the lifeline. The Huajiang Grand Canyon Bridge is not only an engineering achievement, it has been designed as a comprehensive tourism destination. The bridge features an 800-meter glass elevator leading to a double-level cafe inside the tower, glass walkways overlooking the canyon, one of the world's highest bungee jumping platforms, large artificial waterfalls, and extreme sports facilities. The bridge itself is the destination. With a total cost of approximately $280 million, the project was completed, from groundbreaking to full-scale load testing, in just over 3 years. During the August 2025 load test, 96 trucks weighing a combined 3,700 tons were positioned on the bridge, while more than 400 sensors recorded real-time data. The results met the most stringent international safety standards. Media outlets from the United Kingdom, India, and the United Arab Emirates have described it as the bridge with the highest deck elevation in the world, and as a defining symbol of China's modern infrastructure capability. By reducing crossing time from 70 minutes to 90 seconds, the Huajiang Grand Canyon Bridge eliminates dangerous mountain roads, improves logistics efficiency, and lowers transportation costs. More importantly, it has become a key driver of balanced, inclusive, and sustainable development in Guizhou and across southwest China. The Huajiang Grand Canyon Bridge is not merely a holder of world records. It is proof that China is redefining the limits of engineering in extreme environments, and a clear demonstration of how modern infrastructure can transform the destiny of an entire region. And in the end, the Huajiang Grand Canyon Bridge is not really about height. It's about what happens when engineering confronts geography head-on and refuses to accept isolation as destiny. For centuries, terrain defined what was possible here. Mountains slowed movement. Canyons divided communities. Distance shaped opportunity. This bridge changes that equation, not by erasing the landscape, but by adapting to it, working with gravity, wind, rock, and uncertainty instead of trying to dominate them. That is what modern infrastructure looks like at its best. Not spectacle for its own sake, but systems designed to endure, to connect, and to quietly reshape lives long after construction crews have gone. Whether this model becomes a blueprint for the future or a cautionary reference will be debated for decades. But one thing is already certain. In places where geography once said no, engineering has learned to ask a different question: what if we build anyway? And as China continues to test that question across mountains, oceans, and fault lines, the rest of the world is watching. Not because these projects are the biggest, but because they force us to reconsider what infrastructure can mean in the 21st century. When you think of infrastructure in the United States, the first things that probably come to mind are the iconic orange-red cables of the Golden Gate Bridge or the endless stream of cars on the interstate highways. These are, without a doubt, symbols of American pride. After all, the Golden Gate Bridge was completed in 1937, and the Hoover Dam stunned the world way back in the 1930s. But today, let's shift our focus halfway across the globe, to China. There, a groundbreaking infrastructure revolution is unfolding, one that is redefining the scale, the speed, and the technological limits of what we once called engineering marvels. This is the story of China's infrastructure, a story of breathtaking ambition and record-breaking projects, of a nation reshaping its landscape at lightning speed and rewriting the global playbook for what infrastructure can achieve. Can you believe this? While America is still stuck in endless debates, just to renovate a single bridge, China has already built the tallest bridge on Earth, suspended between cliffs as high as a 200-story skyscraper. While American high-speed rail proposals are still stuck in Congress, China's bullet trains are racing at 421 kilometers per hour across a staggering 40,000 kilometers of high-speed rail, more than the rest of the entire world combined. This isn't a sci-fi movie. This is real. This is China, redefining what's possible in engineering, one mega project at a time. To be honest, when it comes to infrastructure, the gap between China and the US might be far bigger than you think. Take high-speed rail, for example. America's first high-speed rail project, the California High-Speed Rail, was approved back in 2008. And the result? 16 years later, it's still not finished. The original budget of $33 billion has ballooned to over $128 billion.
So we're here to talk about the California High-Speed Rail Project. So when originally conceived, the voters of California voted in Proposition 1A that they would have a high-speed rail from LA to San Francisco. It was going to be done by 2020, and it was going to cost $33 billion. And people were excited, they were thrilled. Take people off the road, out of the air, put them on rail, move them quickly. It was an exciting time, exciting promises for an exciting project. Where are we today? Well, today we are severely, no pun intended, off track. And that project, thus far, is going to cost the California taxpayer and the federal taxpayer, at best estimates, $33 to $35 billion. At best, that portion of the project is not going to be completed until 2033, 2035, way after this whole project was to be completed. And with the $15.7 billion already invested in a project that has given you bridges here to my left and to my right, bridges to nowhere, right? But this project, if completed, 400 miles from LA to San Francisco, at best, it'll cost $106 billion. Now, most people will say that is a rosy estimate. There's no way it's going to be completed for $106 billion, which, just to do some simple math, that's 3 times.
Meanwhile, in China, since the Beijing-Tianjin line opened in 2008, China has built over 40,000 kilometers of high-speed rail, enough to circle the Earth at the equator, and then some. And the kicker? China's average construction cost is only 1/5 of California's high-speed rail project. It's like China is riding a rocket while the US is still on a bicycle. From the frozen highlands of the north to sun-drenched tropical shores, China's vast high-speed rail network keeps racing forward day in and day out. Now let's talk bridges. Sure, the Golden Gate Bridge is iconic, but today, 42% of US bridges are past their intended service life, causing an estimated $110 billion in economic losses every year due to aging and deterioration. In contrast, China is home to 8 of the 10 longest sea-crossing bridges in the world. And the construction efficiency? Absolutely staggering. In the US, building a standard bridge can take 7 to 10 years. But in China, advanced pivot technology has made it possible for a 16,300-ton bridge to rotate 180 degrees and connect in just 90 minutes. In 2019, the Beipanjiang Bridge in Hebei completed its pivot in only 85 minutes, a new world record. One American viewer even joked, "Do people in China have more hours in a day than we do?" So where does this massive gap come from? It boils down to fundamentally different approaches to infrastructure. In the US, projects often get stuck in endless rounds of approvals, local opposition, and political tug-of-war over funding. But in China, centralized planning and powerful execution enable the country to rally national resources for major challenges. Just look at the Hong Kong Zhuhai Macau Bridge. More than 1,400 companies and tens of thousands of engineers work together on a single goal: That kind of nationwide coordination is nearly impossible to replicate in the US. And yet, in the face of what many consider a modern engineering miracle, some voices online from the US have raised doubts. With China's current level of industrial development, can this bridge really hold up? I bet it'll need a full overhaul in just a few years. It can't compare to Brooklyn Bridge, USA. This is just a showpiece, no real use. Just trying to flex on the world stage. A waste of money, purely symbolic, with no real benefit to the region. But these dismissive comments reveal less about the bridge and far more about their own comprehension limits. They conveniently ignore the 1,000-plus patented technologies developed during the construction. They overlook the 6.7-kilometer undersea immersed tunnel, built with a precision tolerance of less than 5 millimeters. And they're unaware of the bridge's advanced design, with multi-layered anti-corrosion systems, seismic resilience, and the ability to withstand Category 16 typhoons, magnitude 8 earthquakes, and even a 300,000-ton ship collision. When Chinese engineers declared a 120-year design lifespan, it wasn't a marketing slogan. It was backed by hard data, rigorous testing, and world-class engineering. These unfounded criticisms aren't just about the bridge. They're about the growing unease of watching China's engineering capabilities rise with a speed and confidence the world didn't expect.
Oh God, please, no! No!
Imagine this. Beneath the roaring waves of the Lingdingyang Strait, 33 massive immersed tunnel segments, each as tall as an 8-story building and weighing 80,000 tons, had to be aligned and joined together with Lego-like precision. The margin of error? No more than 5 centimeters. The difficulty? Comparable to threading a needle through a moving aircraft carrier during a hurricane. This was the hell-level challenge Chinese engineers faced while building the Hong Kong Zhuhai Macau Bridge. John Smith, a member of the American Society of Civil Engineers, once said, "Achieving millimeter-level precision in deep-sea immersed tube joints, we used to think that was impossible in the real world." Faced with such skepticism, even ridicule from overseas experts, Chinese engineers responded with quiet determination. Yes, the difficulty is unprecedented. Millimeter-level tolerance in these conditions is an enormous challenge, but that's exactly why we must do it. This is our responsibility as Chinese engineers. We will not be intimidated by mockery or doubt, and no technological blockade can stop our progress. We will stay on site, research day and night, and even if we fail thousands of times, we will never give up. And they didn't. Through relentless effort, they invented a technique called composite foundation treatment, injecting special materials into the seabed to turn soft silt into rock-solid support, capable of holding tens of thousands of tons. During testing, engineers worked 72 hours non-stop, failed 137 times, until they finally achieved a 300% increase in load-bearing capacity. On May 2, 2017, during the connection of tunnel segments E29 and E30, a sudden tidal surge knocked them 3 centimeters off alignment. In that critical moment, China's self-developed dynamic hydraulic adjustment system kicked in, and within just 15 minutes performed a millimeter-level correction. This move didn't just save the project. It rewrote the rules of sea-crossing tunnel construction worldwide. Today, the 55-kilometer-long Hong Kong Zhuhai Macau Bridge is not only the longest sea-crossing bridge in the world, it's a bold symbol of China's engineering prowess. Next, let's talk about water engineering. The Hoover Dam was once a global icon of industrial might, its power output unmatched for decades. But today, China's Beipanjiang hydropower station has taken center stage. Its network of underground chambers stretches over 217 kilometers. That's the length of 300 Empire State Buildings stacked end-to-end. The largest cavern is 438 meter long, 34 meter wide, and 88.7 meter tall, hence can easily accommodate 13 Boeing 737 aircrafts. And in terms of output, it generates 3 times the electricity of Hoover Dam. Even more astonishing, while America's Big Dig in Boston went 220% over budget and suffered decades of delays, China built Beijing Daxing International Airport, a massive starfish-shaped megastructure, in just 4 years. It handles 200,000 passengers a day and secured 60 international patents in the process. From cross-sea bridges to hydropower giants, from high-speed rail networks to clean energy megabases, Chinese engineers are pushing boundaries again and again, turning the impossible into reality. They are building, quite literally, the backbone of a nation's rise. These projects show that China doesn't just export infrastructure, it exports a complete development solution. Even the New York Times admitted, Chinese infrastructure is reshaping the global economic order. So how is China defining the next century of human progress? While the US is still fixing highways from the last century, China is already exploring the ultimate future of infrastructure. As one of the world's largest developing nations, China has used infrastructure as a powerful engine for economic growth. And at the heart of it all are Chinese engineers, modern-day heroes who are quietly reshaping the world. From undersea tunnels to the tallest bridges on Earth, from expressways carved through deserts to ultra-long-distance power transmission grids, each project is a testament to what human engineering can achieve when ambition meets precision. These projects are not just massive in scale. They showcase China's world-leading capabilities in structural design, smart construction, and sustainable technology. Now let's explore these jaw-dropping megaprojects and see how China is redefining what's possible in the world of infrastructure. So why has China earned the nickname infrastructure maniac from the West? It's simple. When the funding is in place, Chinese construction teams can deliver incredible speed without compromising on quality. In contrast, many foreign teams look helpless when compared to China's pace. Take New Zealand, for example. They've been trying to build a mere 300-meter subway tunnel beneath a city center, and after 4 years, it's still unfinished. Now imagine if this project were handed to a Chinese construction team. Not only would 300 meters be done in no time, even 3,000 meters could be completed within 2 years. But of course, there will always be skeptics. Some may ask, if China's construction capabilities are truly that advanced, then why did a Chinese-built office building collapse during the Thailand earthquake? Doesn't that prove it was just another shoddy project? But here's the truth. Isolated incidents like that are the exception, not the rule. Across the globe, Chinese-built infrastructure is renowned for its quality and resilience. Real engineering power isn't judged by one rare failure. It's proven by the countless megastructures that continue to stand tall year after year. Let's look at a stunning example. In Changsha, China, engineers built a 57-story skyscraper in just 19 days. This high-rise was constructed using a modular building block method, where prefabricated sections were assembled on-site at incredible speed. Each module was precisely manufactured in factories, allowing rapid on-site assembly while maintaining outstanding structural integrity and safety. It's a true testament to the legendary China speed and technological excellence. The skyscraper is called Mini Sky City, standing at 200 meters tall with a total floor area of 180,000 square meters, capable of hosting thousands of people for work and living. What's truly astonishing is that this tower wasn't built using traditional brick-and-mortar methods. Instead, it employed modular construction technology. The entire structure was divided into 2,736 modular units, 90% of which were prefabricated in a factory before being transported to the site. On-site, these modules were assembled like giant building blocks, achieving a record-breaking pace of 3 floors per day at peak efficiency. This factory fabrication plus on-site assembly model not only dramatically boosted construction speed, but also ensured remarkable precision and quality. In terms of safety, Mini Sky City was designed to withstand magnitude 9 earthquakes and meets fire protection standards far beyond conventional building. Additionally, the method greatly reduced energy consumption and construction waste, earning it global recognition as a blueprint for the future of urban development. This astonishing achievement once again demonstrates to the world what China speed and China ingenuity truly mean. While others are still questioning, China continues to push the boundaries of human civilization with one engineering marvel after another. In Africa, the Chinese-built Mombasa-Nairobi Railway revolutionized transportation in Kenya, connecting cities that had never been linked by rail before. The deep friendship between China and Kenya continues to flourish to this very day. Thanks in part to the Mombasa-Nairobi railway, communication between the two nations has gotten even closer.
Yeah, with the Chinese experience, they've built the Tibetan railway, they've built long railway lines, passing through the parks. And when they build this, they take into consideration the needs for preserving the environment. Yeah, that experience is important in the African context.
I think most of the challenges you're able to overcome. If you're determined to get something, you will get something. Nature has just a way of opening doors for people who are really determined in life.
This can make me to tell my children, when I'll give birth to kids one time in my lifetime, I'll be telling them about me working with the standard gauge railway, what I used to do here, and they'll be happy that their mom once did something nice in Kenya.
Meaning of the bridge basically is linking this group of people to the other group of people. So as you understand this group of people, the Chinese, and I understand my countrymen, then I connect in terms of language, in terms of way of thinking.
Why is China so eager to spend massive amounts of money on helping Africa with infrastructure development? Some find it puzzling, even questioning whether deeper motives lie beneath China's grand efforts.
Been very concerned lately about China. They're in Africa. They're lending money to countries to build ports and different infrastructure.
To build what?
Port,
And what's wrong with that?
And, well, because...
Countries that need ports, get ports.
But they're making people dependent on... I mean, I know, it's the same thing that we've done, which is
no, it's
horrible
not.
Around the world.
They are far more humanistic than the United States ever was.
Really? Okay.
Absolutely.
Great.
Let me give you an example. Of course they are peddling for influence.
Yeah.
Yeah? But they are non-interventionist. Absolutely non-interventionist in a way that Europeans, the West, has never managed to fathom. The Chinese never asked Apple to go to Shenzhen and produce all the iPhones. It was Steve Jobs that decided that. Yeah? Mm-hmm. It was not China that went to Washington, D.C. and demanded that they buy a third of your national debt. If they hadn't bought it, you would be in serious trouble. When it comes to the influence of China outside its borders, it's quite remarkable that they don't seem to have any military ambitions. Instead of going into Africa with troops, colonially, destroying the country, killing people like the West has done for the last 100 years, what they did was they went to Addis Ababa and they said to the government, we can see you have problems with your infrastructure. We would like to build some new airports.
In the Middle East, China's work on the Khalifa port in the UAE and metro systems in Saudi Arabia redefined construction expectations with record speed and unmatched precision. In Southeast Asia, the Jakarta-Bandung high-speed railway stunned the world. Designed, built, and now operated with Chinese expertise, it marks a major milestone in global high-speed rail development. This project stands as a flagship of China's Belt and Road Initiative, backed heavily by Chinese state-owned giants. It is operated through a powerful joint venture between Indonesian state-owned enterprises and leading Chinese railway companies. Initially projected to cost under $5 billion USD, and opened by 2019, the plan was soon derailed. Construction hurdles and the shock of the COVID-19 pandemic sent costs soaring past $7 billion. Now, the Indonesian government is pushing forward, aiming to extend the 142-kilometer rail line even further. A train running on the Jakarta-Bandung high-speed railway has reached a speed of 350 kilometers per hour for the very first time during a test run. This milestone marks a major achievement. The railway has officially met its design speed standard and successfully completed the interim goals of dynamic testing, which began on May 22nd. Over the past month, the inspection train gradually accelerated, moving from 180 kilometers per hour to 350 kilometers per hour. Now all functionality, performance, and barrier system indicators of the HSR have met the required design standards, paving the way for future trial operations and the official launch of service. In upcoming tests, the train is expected to reach speeds of up to 603 kilometers per hour. This high-speed line, a landmark project under China's Belt and Road Initiative, connects Indonesia's capital city, Jakarta, to another major city, Bandung. Once fully operational, the railway will slash travel time between Jakarta and Bandung from over 3 hours to just around 40 minutes. This is far more than a railway. It's the embodiment of speed, the hallmark of innovation, and a testament to engineering brilliance. Moreover, it marks a crucial milestone in China's infrastructure going global. So if we want to judge the true level of Chinese infrastructure, we should look at the projects still running strong, still serving millions, rather than magnify the outliers. Why are foreign teams so slow? One major reason is the 6-hour workday culture. Workers clock out on time, no overtime, no exceptions. Half the time is spent chatting, the other half actually working, leaving perhaps 3 hours of true productivity per day. And then there's the pampering. Too sunny? No work. Raining? No work either. Harsh weather? Take the day off. With that kind of mindset, how can projects possibly move forward? In contrast, Chinese construction crews are famously efficient. In China, if a skyscraper takes more than 2 years to complete, it's considered delayed. From high-speed rail to massive expressways, China seems to complete a mega project almost every day. Just 30 years ago, China had 0 miles of expressways. Today, it boasts the world's longest highway and high-speed rail networks, leaving the US far behind. This is why Chinese infrastructure continues to stun the world. A rare combination of speed, precision, and sheer scale, redefining what modern construction is capable of. With each mega project built, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. If you've ever seen bridges stretching for miles, skyscrapers that pierce the clouds, or futuristic high-speed trains racing across the landscape, chances are you've already witnessed China's astonishing infrastructure in action. But today, we're not just here to admire these engineering marvels. We're going to compare them with another global powerhouse, the United States. Why this comparison? Because when it comes to building the future, the world's 2 largest economies take very different paths. As of 2023, China has built over 42,000 kilometers of high-speed rail, more than the rest of the world combined. To put that in perspective, if you connected all that track end to end, it would circle the Earth once. And it's not just about the numbers, it's about the speed of construction. Take Beijing Daxing International Airport, for example. With a $12 billion budget and a terminal the size of 97 football fields, the entire project was completed in just 4 years. But this isn't just architecture. It's a national strategy designed to connect 1.4 billion people and energize the economies of all 34 provincial regions. In the US, the picture looks very different. According to the American Society of Civil Engineers, 65% of US roads are in poor or mediocre condition, and over 45,000 bridges need major repairs.
Roads and bridges are vital to the country. The ability to freely move goods, services, and people across our nation directly contributes to our economic place in the world.
There's no question we're not making adequate investments in our transportation infrastructure. It's more expensive today to maintain what we have than it was to build it originally.
We're still driving on roads that my grandparents paid for and built. Our average bridge age is 75 years. Well, they were built to be 50-year bridges. One bridge that carries 90,000 cars a day, the nearest detour is an 11-mile detour. So if that bridge had to shut down, we'd be looking at 1 million miles a day of extra traffic while that bridge was shut down and being rebuilt.
The majority of our population lives in metropolitan areas, so our highways are greatly congested.
When you have congestion problems, time is money, and that's money lost to that business that is trying to get their product to the marketplace. Same thing for a business person whose time is very valuable.
We all work somewhere, and all of those jobs are dependent on that infrastructure working for us.
We need to make some more investments for the future. We have to look at the whole problem.
We have been working for many, many years, over a decade, to bring down the current long structure of a bridge down to street level, to turn that into a boulevard. And of course, the other side of that coin is if you don't invest in your infrastructure and you do have bad roads and you do have bad bridges, it doesn't help you with economic development.
Meanwhile, China's road network quality ranks among the top 30 globally. The difference is even starker in high-speed rail. While China's trains zip at 421 kilometers per hour, the US has no true high-speed rail network. It is shocking and incredible that the latest bullet train developed in China can reach an amazing speed of 603 kilometers per hour. Amtrak's Acela, often called high speed, tops out at just 240 km/h, and that's only on a short stretch between Boston and Washington, D.C. This gap in infrastructure doesn't just highlight differences in engineering capability, it reveals two completely different development philosophies and system advantages. In the U.S., infrastructure has long been trapped in a vicious cycle: political gridlock, funding shortages, and delayed maintenance. Responsibilities between local and federal governments are often unclear, and interstate projects face endless red tape, leaving roads and bridges operating far beyond their intended lifespans, with little hope for timely repair.
We're going to start spending on infrastructure big, and not like we have a choice. It's not like, oh, gee, let's hold it off. Our highways, our bridges are unsafe.
The federal government's role in infrastructure is fairly narrow to certain types of things: interstate highways, major roads, and bridges. Infrastructure encompasses much more than that. It includes things like the electric grid, which is privately owned for the most part. It includes water and sewer lines, which are mostly owned by municipalities, local streets. Right now, some of the biggest needs are water and sewer systems in local governments. Many of those places, like Flint, Michigan, they're very poor cities. If they raise water and sewer rates, it's going to be poor people paying them.
The president has said that not all of the $1 trillion will come from the federal government, that he would like to see private capital also contribute. So is there money in the form of private capital to help with the infrastructure needs in the country? The answer is absolutely yes. The question is, are there attractive returns? Because those investors have many places that they can invest their money.
In terms of basic ways that you can pay for infrastructure, you can simply raise taxes and pay for it with cash. What happens if the toll money falls short? Bonds have to be paid back. Private investors want to make a return. So really, the people who are going to be paying for it is us, either in the form of higher taxes, higher fees, higher tolls. There's just no such thing as free money.
China, on the other hand, leverages its centralized coordination system, allowing for long-term planning and rapid execution. As a result, highways and railways have undergone explosive growth. Today, China's total expressway mileage ranks #1 in the world for consecutive years. Its 8 vertical and 8 horizontal high-speed rail grid covers 92% of all cities with over 500,000 residents, creating a half-day living circle in a truly unified national transportation network. What's even more worth noting is how infrastructure is quietly reshaping the economic development models of both nations. In China, the transportation network is deeply embedded into regional coordination strategies. High-speed rail isn't just about getting people from point A to point B. It's fueling industrial upgrades and population mobility along its corridors, helping major initiatives like the Chengdu-Chongqing Economic Circle and the Yangtze River Delta Integration Plan take root and thrive. Meanwhile, in the U.S., aging infrastructure has kept logistics costs stubbornly high, limiting the economic potential of the Midwest and widening the gap between regions.
The Department of Transportation estimates that the U.S. needs to spend at least $124 billion a year to keep roads and bridges in good condition. In 2010, all levels of government combined only spent $100 billion, $24 billion short.
This contrast reveals a deeper truth. World-class infrastructure isn't just a hard asset, it's also a form of soft power that defines national competitiveness. While China is already planning for intelligent railways and magnetic levitation trains, the U.S. is still stuck debating how to fix what's already broken. This generational gap in infrastructure development may have only just begun to show. Cost is another major factor. China's Three Gorges Dam, the largest hydroelectric project in the world, was completed in just 17 years. The Three Gorges Dam, because it has an exceptionally large solid granite river valley. In the first segment of the river, about 1 million square kilometers of land has been taken under control, and the average amount of water passing through the river each year reaches 500 billion cubic meters. It is the world's most gigantic concrete structure. It took 40,000 employees. They needed nearly 6 billion gallons of concrete and 463,000 tons of steel, which is enough to construct 63 Eiffel Towers. They installed 32 huge generators that weigh 6,000 tons each. With the activation of these 32 generators, the Three Gorges Dam has reached its full capacity. These 32 main turbines, each with a capacity of 700 megawatts, and 2 small turbines, each with a capacity of 50 megawatts, can generate enough electricity to run 15 nuclear reactors, way enough to provide energy for 60 million people. The total cost? According to China, it costs $37 billion to complete the project. Now compare that to California's high-speed rail. Back in 2008, it was originally budgeted at $33 billion. But today, the price tag has soared to nearly $128 billion. And after 15 years, only a small portion of the rail line is finished. So why such a massive gap? In China, centralized planning allows for faster land acquisition and streamlined approvals. In the U.S., infrastructure projects often get stuck in years of lawsuits, community opposition, and political gridlock.
What is the state of infrastructure in this country today?
We are really falling behind and falling apart.
Marcia Hale is with the bipartisan group Building America's Future, which raises awareness of the state of U.S. infrastructure.
We've got a construction site right ahead of us here.
The American Society of Civil Engineers gave the U.S. a D+ for overall infrastructure this year after a comprehensive review that included the nation's roads, bridges, and waterways. Their solution? Invest an estimated $3.6 trillion by the year 2020.
Our roads, our bridges, our schools.
It is also time to rebuild our crumbling infrastructure.
America, this is how we truly build back better.
China is also leapfrogging in tech. Their floating tunnels and 3D printing technology are pushing engineering boundaries, while U.S. infrastructure often relies on decades-old technology. For example, China's Beidou navigation system, a rival to GPS, powers smart infrastructure projects nationwide, from traffic management to disaster prevention. So it means that precision guidance systems cannot be controlled or jammed by the U.S. anymore. The ICAO has now recognized China's Beidou navigation system as a global standard for civil aviation, which is more accurate than the American GPS. The fact is that the Beidou system has already been used worldwide and has an astronomical number of users. In the U.S., many cities still struggle to upgrade basic systems, like lead pipes and water supply networks. What drives these differences? It boils down to policy, funding, and culture. China's 5-year plans allocate massive state funding to infrastructure, while the U.S. depends more on fragmented local budgets and private investment. Culturally, China values long-term planning, as seen in projects like the Belt and Road Initiative, which aims to connect Asia, Europe, and Africa over decades. In contrast, U.S. infrastructure often prioritizes short-term political goals, leading to delays and budget overruns.
Just a few years ago, the stock market's at 25,000. Corporate profits are the highest they've been in decades. The rich keep getting richer. And our friends on the other side said, what do we do now? Let's do a tax cut where 83% of it goes to the top 1% of the wealthiest people. Fast forward a few months, global pandemic, 36 million people unemployed, 40% of families who have a worker that makes $40,000 a year and less lose their job last month. 4 million people didn't pay their rent, and the Republican Party says, we don't have any money to help you. Are you kidding me? Where do you guys live? Food lines around the blocks at our food banks in the United States of America. 1 in 5 kids are going hungry. Your party can't even get food to them. This isn't a wish list. If it's a wish list, it's for the working class people.
So, who's winning the infrastructure race? The answer isn't simple. China's rapid growth has raised concerns about environmental impact and debt risks, while the U.S. is finally investing billions in the bipartisan infrastructure law.
After years and years of infrastructure week, we're on the cusp of an infrastructure decade that I truly believe will transform America.
The $1.2 trillion bill includes $550 billion in new spending, including $110 billion for roads and bridges, $25 billion for airports, and the largest federal investment in broadband ever, $60 billion. All of this is extremely important and needed, with the biggest investment in bridges since the interstate system. With former Vice President Harris presiding, all 50 Senate Democrats voted to support the bill, along with 19 Republicans, including Minority Leader Mitch McConnell. It's a good day. Elections matter. But the bipartisan spirit in the Senate was gone by lunchtime, with Democrats taking their first procedural vote on a separate $3.5 trillion budget bill packed with other priorities that they intend to pass in the face of united Republican opposition. This budget resolution is a dream for those who want to socialize America. It's a nightmare for working people. But one thing's clear: the way these two giants build their futures will shape global economics, trade, and technology. In the field of hydraulic engineering, China has also achieved global acclaim. The South-to-North Water Diversion Project, the largest water transfer system in the world, aims to alleviate severe water shortages in northern and northwestern China. Divided into 3 routes, eastern, central, and western, the project reallocates abundant southern water resources to water-scarce regions across the country. The total length of the engineering project is 1,100 kilometers, and the total investment exceeds $62 billion. To date, the project has transferred hundreds of billions of cubic meters of water, benefiting hundreds of millions of people, while effectively improving ecological conditions and the overall quality of life in the north. Throughout the construction process, engineers face major technical challenges such as tunneling under the Yellow River and managing expansive soils. Yet through persistent research and innovation, Chinese engineers overcame these difficulties and ensured the successful completion of this national megaproject. China's rapid rise in infrastructure, it's no accident. Behind it, a deep foundation in science and technology, and a vast reserve of skilled professionals. The country boasts a massive team of highly qualified researchers, engineers, and technicians who continuously drive innovation in the infrastructure sector. At the same time, China's industrial system powers the build. From cutting-edge materials to precision machines, it delivers at scale. In addition, China's infrastructure boom didn't happen by chance. It was driven by long-term government planning, strong policies, and massive public investment. One successful mega-project after another. Compared to the United States, China has demonstrated a unique set of advantages and growing competitiveness in infrastructure development. While the U.S., once a pioneer in global infrastructure, now struggles with aging facilities, funding shortfalls, and bureaucratic delays, many of its roads, bridges, and railways are in disrepair and badly in need of upgrades. In contrast, China continues to invest heavily, accelerate innovation, and complete projects with unmatched speed and precision. Its infrastructure model not only supports robust domestic development, but also offers a valuable reference for other countries seeking to modernize their own systems. And the story is far from over. The miracle of Chinese infrastructure continues to unfold. In the years ahead, China is poised to explore ever deeper underground engineering, expand transportation networks to new frontiers, and take on construction challenges in even more complex environments. With fearless determination and world-class technical expertise, China is reshaping the very definition of what human engineering can achieve, paving the way for a future that is stronger, smarter, and more interconnected than ever before. Do you think China's model can work in other countries? Or does the US have an ace up its sleeve? Don't forget to subscribe and hit the bell icon for more deep dives like this one. Thanks for watching.